Alright, so the basic question for Quideo number 2, we're given a table of Professor Moore's time for swimming 2,000 yards and his pulse rate. So you can see that here. Question A asks us to verify that a linear model appropriately models the data and then state the equation of the linear model. So I entered the points into my list 1 and list 2 in my graph. And then I looked at the scatter plot and I saw that there was a linear model. So then I just went into my calculator and did a linear regression, which would be going to stat and then going to calc and then scrolling down to linreg. And it gave me this equation based on this model where x is my time and then this is my y-intercept and this is my slope. So question B asks us to predict the professor's pulse rate based on his time, which is 34.3. So what you do is you plug it into the equation right here for your x, and you get 147.4. And then it says his actual pulse rate was 152, and it asks us how accurate it was. I'd say it was pretty accurate. It was about 5 under his actual pulse rate. And then question C asks us if the pulse rate was 152, it wants us to predict the swimming time. So basically that means that our x and y has been switched. So what you do is you go into your calculator and you hit linreg, and then you edit so that list 2 and list 1 are switched for your x and y. And then it gave me this equation where x is now my pulse rate and then my y has changed to my time. So I have this equation now to go by. So what I do is I plug 152 in for my x, and it gives me 34.372 minutes, which was very close to the 34.30. So yes, it's very accurate. It asks us to say how accurate it is. It is very accurate. And then question D asks us to explain why there need to be 2 different lines for parts A and C. And that's simply because your x and y variables were switched when you had to find the pulse rate and then when you had to find the time. So that required a new equation.